Right now, Europe's got no way to intercept what Russia's already used in combat. On January 10, 2026, the Oreshnik hit Ukraine at Mach 10. No NATO system responded, none. And the €1 billion the EU approved in December 2025 to solve this. It funded a system that won't exist for a decade. What the headline didn't say, this €1 billion isn't a shield. Not yet. It's the blueprint for one. A commitment to build something that doesn't exist yet, against a threat that's existed since yesterday. What's protecting Europe right now? That's the real question. And before HIDEF becomes operational before 2030, the answer is much more uncomfortable than any official announcement will admit. This isn't speculation. It's NATO's own documented conclusion, recorded in October 2025. The alliance didn't say the problem was technological. NATO said the problem is industrial and procurement related, that the European institutional machinery can't move fast enough to close the gap, while the adversary's already advancing. So what exactly is this €1 billion? Of the total approved by the European Defence Fund's 2026 work programme, €168 million goes specifically to hypersonic counter-missiles funding, the programme called HIDEF, the European Hypersonic Defence Interceptor. Another €68 million funds a hypersonic glide vehicle demonstrator, applied research to better understand the threat they are trying to neutralize. HIDEF was launched in 2022. Formal funding came in 2025. The estimated operational date is the 2030s. This creates a window of at least 4 years, from 2026 to 2030, where Russian hypersonic weapons are real, are operational, have already been used in combat, and there is no European interceptor capable of stopping them reliably. We are inside that window right now. When you hear €1 billion European hypersonic shield, what you're really hearing is Europe just formalized the funding for a solution that still needs a decade to exist, to face an arsenal that is already operating today. To understand why this gap is so severe and why existing systems aren't just insufficient, but fundamentally inadequate, you need to understand what hypersonic really means. And the difference isn't just speed. Hypersonic starts at Mach 5 times the speed of sound, about 6,100 kilometers per hour. But speed alone isn't the issue. Conventional ballistic missiles already hit hypersonic speeds during descent. They've passed Mach 5 by the time they're diving at the target. Why can modern defense systems intercept them? Predictability. The trajectory's calculable. Impact points can be estimated with enough precision. Interceptors can reach the right place at the right time with enough margin to succeed. Modern Russian hypersonic systems are categorically different. They combine speed with maneuverability. A hypersonic glide vehicle doesn't follow a fixed ballistic trajectory. It glides, changes direction, adjusts its route mid-flight based on real-time data. And it does this at Mach 10 speeds, roughly 12,000 kilometers per hour. Think about what this means for existing interception systems. A system like the Patriot, NATO's main air defense interceptor deployed across Europe, was designed for conventional ballistic missiles and aircraft. It detects a moving object, calculates its trajectory, and launches an interceptor to where the target will be. It works because the target's behavior is predictable. The system can solve the equation. Where will the target be in a few seconds? Right now, these batteries scattered across the continent operate under the same structural constraint. Against a hypersonic glide vehicle, this calculation breaks down completely. The radar detects the object. The system starts computing the trajectory. The target changes direction. The system recalculates. The target changes again. All of this happens in fractions of a second, while the missile approaches at speeds that compress the operational decision window to seconds, not minutes. The engagement geometry becomes impossible before the interceptors even launched. THAAD, the American High-Altitude Ballistic Missile Interception Network at Allied bases, hits these same physical barriers. Both were optimized for a different threat. Here's the thing. These systems aren't deficient at what they were designed for. The Patriot works brilliantly against conventional missiles. THAAD does too. The problem is that modern hypersonic systems represent a different category of challenge entirely. It's like saying a truck's braking system doesn't work on a motorcycle. Not a design flaw, a category mismatch. There's also the problem of absolute response time. At Mach 10, a missile detected 300 kilometers away has roughly 90 seconds to hit its target. In operational terms, the entire decision chain detection, threat verification, authorization, launch, guidance must happen in a minute and a half. For a vehicle that changes trajectory during this window, it gets even tighter. It's not about having faster radar. It's physics. Time simply isn't enough for the existing interception model. And Russia didn't wait for Europe to solve this problem. They built 3 systems that exploit exactly this gap, and all 3 are operational right now. The first is the Kinzhal, also spelled Kinzhal, an air-launched hypersonic missile capable of Mach 10+, with an estimated range of up to 2,000 kilometers, depending on launch platform. The Kinzhal isn't operational on paper. It was the first Russian hypersonic system used in actual combat in Ukraine. The second is the Zircon, a hypersonic cruise missile originally designed for naval launch, with estimated speeds between Mach 8 and 9. Where and how the Zircon was most recently tested completely changes the risk map for any European, and we'll get to that in a moment. The third is the Oreshnik, a hypersonic ballistic missile that reaches Mach 10. On January 10, 2026, the Oreshnik was used in combat against Ukraine. Putin publicly declared it immune to all existing defense systems. We'll dig into that event in more detail shortly. There's also an economic dimension. A Patriot battery costs hundreds of millions of dollars. The interceptors cost $4 million each. Russian hypersonic systems cost a fraction of that to produce compared to interceptors designed to stop them. The math favors the offense. For every hypersonic attack, defense has to spend substantially more and potentially fail anyway. And one of the 3 systems we just named was tested from a location that puts European capitals within direct striking distance. Now let's talk about what Russia has actually done, not theory, not estimates, but what it's already executed, documented, and repeated. The Kinzhal entered operational use in Ukraine and became the first hypersonic system in modern warfare to be fired at enemy targets. When Ukraine tried to defend itself using Western-supplied systems, results were inconsistent. Under very specific conditions, early warning, favorable engagement geometry, proper battery positioning, the Patriot managed some engagements of the Kinzhal. But that's not reliable defense. It's a circumstantial result under controlled conditions. Not a general, systematic defense capability against this threat in a real operational scenario. The Kinzhal also demonstrated something fundamental. Russia is willing to use these systems, not just in military parades, not just in controlled tests, in actual conflict against real infrastructure with real consequences. The line between a demonstration weapon and an operational weapon has been crossed. And once crossed, that line can't be uncrossed. The operational precedent exists. And any future strategic calculation must treat it as an established fact, not a hypothetical possibility. What makes this even more concrete isn't just what Russia has already used, it's from where they can use it. And that where has a name: Kaliningrad. Kaliningrad's a Russian exclave separated from Russia's main body, wedged between Poland and Lithuania on the Baltic Sea. From a strategic standpoint, it's Russia's most forward launch point toward Western Europe. And that's where this gets disturbing for Western Europeans. In September 2025, Russia held the Zapad 2025 exercises, West 2025, in Russian. The scope was massive. Over 100,000 military personnel, tactical nuclear systems in the simulations, And the critical detail. The Zircon was tested from Kaliningrad. Kaliningrad is roughly 1,000 kilometers from Belgium. The Zircon has an estimated range of up to 1,000 kilometers. Brussels, home to NATO's main institutions and political and military headquarters, is within striking distance of a hypersonic attack launched from existing Russian territory. Not from a weapon in development, from a system that was tested in September 2025. Poland, Germany, the Netherlands, Belgium and parts of France all fall within strike range from Kaliningrad. Practically every major center of political, economic and military power in Western Europe is on this map. The geometry of Kaliningrad means a hypersonic system doesn't need to fly over neutral territory or cross airspace that provides early warning. The attack vector goes straight over the Baltic Sea or over alliance member countries that lack independent hypersonic interception capabilities. Russia's exploited this strategic position for years. What changed in September 2025 is that there's now a tested vehicle that turns this geographical advantage into a confirmed operational range. For Zapad 2025, Russia also demonstrated integrating conventional forces, tactical nuclear systems, and hypersonic platforms in a single operational scenario. This isn't just a weapon test, it's a rehearsal of doctrine. The type of campaign Russia considers viable, practical, and coordinated across multiple domains simultaneously. NATO Secretary-General Mark Rutte made a statement in December 2025. The same month, the EU approved the €1 billion fund warning that Russia could be ready for a conflict with NATO within 5 years. 5 years, not decades. Not some abstract threat in the distant future. There's a specific geopolitical logic to why Kaliningrad's such a valuable launchpad for Russia. Any ground conflict involving the exclave requires crossing NATO territory, Poland or Lithuania, which automatically triggers Article 5. That makes Kaliningrad functionally an unsinkable aircraft carrier, permanently stationed on the alliance's eastern flank. Unlike a real carrier, it can't be repositioned, can't be evaded, and can't be preemptively attacked without triggering a full alliance response. Kaliningrad's geographical logic has been part of Russian strategy for decades. The exclave's been systematically armed with missile systems, radar, and now proven hypersonic capabilities. What's new is that the system turning Kaliningrad into a continent-spanning threat exists, works, and was demonstrated in a live exercise in September 2025. Zapad 2025 wasn't just a weapons test, it showed Kaliningrad can project hypersonic force into the heart of Europe. And what happened a few months later drove this point home. On January 10, 2026, Russia used the Oreshnik in combat for the first time. Target: Ukraine. Weapon: a hypersonic ballistic missile that reaches Mach 10. What made this event different wasn't just the use itself. It was what didn't happen on the defense side. Nothing intercepted the Oreshnik. No system was positioned to even try with reasonable expectation of success. Vladimir Putin made a statement that needs analyzing carefully, not because he's neutral, but because it's technically consistent with known defensive systems. Putin claimed the Oreshnik is immune to all current defense systems. Western technical analysts met this with notable silence. Because they can't prove otherwise. THAAD was designed for ballistic missiles with predictable trajectories. The Patriot has the category limitations we already discussed. No European or NATO system was built to intercept the Oreshnik's flight profile. What was NATO's response? The EU's response. Statements of concern, reaffirmations of Ukraine's support, but no announcement of a defensive capability that could have changed the outcome of January 10th. There's logic to that silence. You don't announce what you don't have. Now go back to Rutte's statement from December 2025 made 2 weeks before the Oreshnik attack. 5 years until Russia is potentially ready for conflict with NATO. The high-def window of vulnerability runs from 2026 to 2030 by definition, 4 of those 5 years. The math produces an overlap that no official document will state in such blunt terms, but that basic arithmetic makes hard to ignore. The January 10th Oreshnik use was operational proof of concept. Not that Russia will attack Europe, but that if it does, the tool exists, it works in real combat, and Europe's got no reliable response right now. Strategically, this is more subtle than it seems. Even without an actual attack, an uninterceptable weapon shifts deterrence calculus. The threat of use produces effects, because NATO planners must incorporate the fact that an Oreshnik first strike can't be met with active defense. This changes how potential conflicts are thought about, escalated, and discussed diplomatically. An uninterceptable weapon doesn't need to fire to carry strategic weight. What's that €1 billion actually building? Good question. The HIDEF program, European Hypersonic Defense Interceptor, is led industrially by the Sena Group, a Spanish engineering company with extensive aerospace and defense credentials. Technical coordination comes from Diehl Defense, a German company specializing in weapon systems and precision-guided munitions. Surrounding these two anchors is a consortium, including MBDA, Europe's largest missile manufacturer, Airbus Defence and Space, Hensoldt for sensors and radar, Norway's Kongsberg, Spain's Indra Sistemas, and Sweden's Saab. 6 countries are formally part of the program: Spain, Germany, France, Italy, Finland, and the Netherlands. This consortium represents real, distributed expertise. MBDA has direct experience developing high-speed missiles and advanced guidance systems, Europe's largest missile manufacturer with decades in interception systems. Kongsberg has proven credentials in precision-guided weapons and platform integration. Airbus brings scale assembly capacity, plus access to avionics and advanced materials. Hensoldt specializes in precision sensors and radars critical for tracking and engaging maneuvering hypersonic targets. This isn't a paper program. It's an industrial initiative with expertise distributed across multiple countries with strong defense sector traditions. The €168 million for hypersonic counter-missiles funds development of an interceptor capable of engaging hypersonic vehicles maneuvering at high speeds. The core technical problem is guidance. How do you guide an interceptor to a target that doesn't follow a fixed trajectory, changes direction during engagement, and moves at speeds where every second of delay matters critically? This requires radar capabilities, signal processing, and trajectory prediction algorithms substantially different from systems like the Patriot. The €68 million for the hypersonic glide vehicle demonstrator serves a complementary goal: to understand exactly how these vehicles behave in actual flight, how they maneuver, what their physical limits are, and where the windows of vulnerability lie that an interceptor can exploit. HIDEF's engineering challenge is categorically different from any previous missile defense system. Existing systems assume they can predict where the target will be. HIDEF must be designed from scratch to engage targets that actively defy prediction that change direction while the interceptor's in flight, exploiting the defending system's calculation lag. This isn't incremental engineering built on the Patriot. It's an entirely new system category. New guidance architecture, new real-time data processing, new sensor standards developed and validated from scratch. But what does operational mean for weapons systems? This term needs qualification. Weapons systems go through phases: proof of concept, prototype, qualification, production, deployment, and operational integration. Each step taking months to years. Operational in 2030 likely means the first units deployed, not substantial defensive coverage over European territory. The gap between first prototypes and defensive coverage that matters at scale could be years beyond that. And while this cycle completes, Europe's vulnerable. The timeline comparison reveals exactly how big this gap is. HIDEF was launched in 2022. The Russian systems it needs to intercept. Kinzhal was operational around then, Zircon was in advanced testing, and Oreshnik was in accelerated development. While HIDEF was still in conceptual development, Russia was already firing these systems on the battlefronts. The adversary has completed the cycle. Europe is just beginning. The problem isn't technical competence, it's time. And in defense, time isn't just a technical issue, it's fundamentally industrial. In October 2025, NATO documented a conclusion that deserved far more coverage than it received. The problem with European hypersonic defense is not technological, it is industrial and procurement related. That distinction sounds technical. It's not. If the problem were technological, it'd mean Europe doesn't know how to build an effective hypersonic interceptor, that the physics haven't been solved. No clear engineering path exists. In that case, the €1 billion would be a basic research gamble with uncertain results. But NATO's analysis says something else. Europe knows what it needs to build. The problem is the institutional machinery, defense procurement, industrial supply chains, production capacity, contracting mechanisms. Simply can't move fast enough. What stopped Europe from having a response ready on January 10th, 2026, wasn't lack of money. It was three structural problems that existed before a single euro was spent. The first is deindustrialization after the Cold War. For decades, European countries scaled back arms production, assuming large-scale European conflicts were over. Factories shut down, production lines deactivated. Skilled workers left the industry. The specialized knowledge for advanced weapons systems scattered. The peace dividend was real. But now Europe needs to rebuild industrial capacity essentially from scratch. The second problem is procurement systems built for a different pace. Defense contracting in most European countries evolved assuming you'd have decades to develop and deploy systems. Extensive parliamentary oversight, multiple review cycles, competitive bidding, approval layers, all make sense in peacetime. They create severe friction when you need rapid response against an operational threat. The third problem is political fragmentation. 6 countries in high DF means 6 different parliamentary calendars for budget approval. High DF can't move faster than the slowest one. 6 sets of national requirements, 6 budgets with distinct priorities, 6 certification systems. European defense cooperation is a genuine political achievement, but it comes with a structural speed penalty you can't ignore when the adversary has a centralized command structure. The result is the 2026-2030 window. This isn't a worst-case scenario from pessimistic analysts. It's the window confirmed by NATO's own analysis, high DF's documented timelines, and Russian operational timelines. For at least 4 years, Russia will have hypersonic weapons they've already used in combat that Europe can't reliably intercept. But you're hearing these terms right now, and the math doesn't change depending on who's crunching the numbers. That's what already compromised means in the title. It's not a prediction of the future. It's a description of the present. Rutte said Russia could be ready for a conflict with NATO in 5 years. 5 years from December 2025 is 2030. High Def's conservative estimate is initial deployment in the 2030s. If Rutte's warning is realistic, and there's concrete reason to take it seriously, the vulnerability timeline and potential risk timeline overlap. That should cause significant operational discomfort for any European military planner. What NATO's October 2025 analysis also implies, without stating it directly, is that Europe doesn't just need more money in the current system. It needs structural reforms in how defense is procured, produced, and deployed. €1 billion in the current system yields a different outcome than €1 billion in an overhauled system. But there's evidence another approach could work. In February 2026, a joint venture startup between German and British companies conducted Europe's first private hypersonic missile test in Norway. Mark 6 or higher. Not a government program, not a NATO initiative. A private company, using its own resources and decision-making speed, testing hypersonic capabilities in European airspace. This matters because it demonstrates private sector speed is structurally different from institutional speed. Clear economic incentives and less bureaucratic friction compress the development cycle significantly. What takes decades in government procurement can happen in years when decision-making frameworks are different. That February 2026 Mach 6 Plus test by a startup was a signal, not that the problem is solved, but that physics and engineering can advance faster than current institutional processes allow. But these signals, as promising as they are, don't close the window alone. So let's go back to what we know for sure and what the next 4 years will demand answers for. Can any current NATO system reliably intercept the Oreshnik? No. The January 2026 combat use proved it. Putin declared it publicly. Western technical analysts can't refute the claim with evidence. Will high-def close this gap? Eventually, maybe, but not before the 2030s, assuming NATO's identified industrial bottlenecks are effectively addressed. Operational in 2030 means first units, not substantial defensive coverage. Is anyone moving faster? The private sector, potentially, as the February 2026 test showed. But faster still needs to become an integrated, certified system deployed at real military scale. What does the €1 billion represent? A real, necessary step. A step toward closing a gap that already exists, against a threat already operational, on a timeline already lagging behind the adversary. The question the next 4 years will answer, one way or another, is whether this window can be navigated without the kind of event that no defense budget can calculate in euros. If this analysis matters to you, if you want to understand what's happening behind the headlines, in the real numbers, in the timelines that count, subscribe to the channel. If you know someone interested in these topics, it's a conversation worth sharing. Questions about high DF, how to narrow this vulnerability window, or the systems we've analyzed? Drop them in the comments. The conversation about what protects Europe doesn't end here. The inability to